TwitBooks.tv here, and what we're looking at is part 3 of antiderivatives. We've got a little word problem here. So in the previous parts, we looked at inverses, the relationship between antiderivative and derivative, and then we did some examples in part 2. So now in part 3 here, we'll just do a nice, simple, straightforward word problem. Okay, so kind of what we've got here is TwitBooks. It's a nice little social online group kind of thing going on. And I take a moment, read through this problem. Now, one of the things you want to do is kind of use those steps to do a word problem. First thing I want to identify is what our goal is. And in this case, we actually have two, because the question's at the end. We have two questions, two actions. The first one is to find an expression about the membership. And usually what that means is make a formula with membership with T in it. So we're going to make a formula. T is going to be in the formula, and it's going to be a way we calculate our membership. One thing I want to bring your attention to while I can is right here, what we have here is M of T. It's a small m. And for the questions asking for a big M. In some math textbooks and some math classes, you basically kind of use the general relationship. If you're using the same letter, lowercase and uppercase, there's a relationship here. Usually what happens is the lowercase right here, small m, is going to be the rate of change, and that's what we have, the rate, and then we're using small m. And then in the question, it's asking for their total, and it uses the capital M. And you might see that notation used a lot. So capital M, the capital is used for the total, and the lowercase is used for the rate. Okay, so that I just want to bring that attention to you. And then also our second question that we'll have here, second thing to do, is that we've got to do an estimation. We'll actually do a calculation midway through 2008. And so basically what we're looking at, we're going to calculate. We're going to make a formula, then we're going to calculate with T equals 3.5. And so that's our goal here. Some information that we've got. We were given a rate of change, which was kind of nice. And again, that small m there, usually a way to do it. We do have another piece of information right here that 1 million is at time 0. That started 2005, 1 million. T equals 0, m equals 1, the capital M. And that's a reason being why am I using T equals 0 for that number is because it says down here at the very end, T is in years since the start of 2005. That makes 2005 go with T equals 0. So that's where I'm getting that information from, because that's how they want us to start time. Time is starting, the clock is starting in 2005. Now, some relationships I'm playing with. So whenever I do a word problem, I'm kind of like trying to drum up some things in the back of my mind. What do I have to play with? Well, one of the things I have to play with is that there's a relationship between the derivative, the rate formula, and the original. So what we have here is the idea to integrate the rate. So if I start with the rate, I'm going to integrate it to get the original formula, to get the total formula. And so that's a relationship that I keep in mind. And then just kind of thinking the process for integrating, it's the reverse process for derivatives. That's why they call it the antiderivative. And so instead of subtracting powers, we're going to add 1 to the power. Instead of multiplying, we're going to divide. Okay, so I'm just keeping those things in mind. So I'm going to start with the rate. Looks like I'm going to integrate and then get the total value. And that's what I've got here for my strategy. I'm going to take the antiderivative of that rate formula that's been given. And then I'm going to find the value for C, that constant of integration. And then I'm going to plug in the value, that 3.5, to get my number, my membership in the mid-2008. All right, so let's do the steps now. So we're starting with this rate formula. So I'm going to do the antiderivative. Remember that integral sign right here, that long S in a way. That's indicate to do the antiderivative. And when we do that, we add 1 to the power and then divide by the new power. So I add 1 to this power, make 3. Divide by the new power, 12 divided by 3 comes the 4. I got T to the first power. I add 1, make 2. Divide by that new power, divide by 2. That's where the 6 is coming from. And then when an 8 constant by itself, that's really, you can think of it as T to the 0 if you want to. So when you add 1 power, that makes it T to the first. And then when you divide by 1, doesn't change it. Or you can just kind of remember, hey, This is the derivative. How do I get a derivative that's equal to 8? Well, I must have started with 8t. All right, and then plus the constant of integration. And we'll be using the c. So in this example, I'm going to show you why the value of that c, where it's coming from. All right. Next thing I want to do is actually calculate that value for C. And what I use is I use the information that was given to us. We were told that we had 1 million memberships at the beginning, or in that first year, in 2005, when we started the clock. And so with that data point, I can plug that data point in. I can plug this 0 in for all the T's. And then this 1 here is the number of memberships, 1 million. And so I can plug in 1 for the M there. And so that's what I do. So I'm plugging in zeros for the T's, and I'm making M equal to 1. And now we can actually solve for C. Well, all these zeros are going to go away. We're going to end up with just C equals 1 in this case. For polynomials, it works very quickly to find the C value. It's very, very easy to find the C value, especially when you get the initial value. Normally, in polynomials, the C value is the initial value. This initial value is the value that we have at time 0. And what I mean by polynomials, those things with powers here. Exponentials and logarithms, all bets are off. Doesn't hold the same thing. So this relationship that C is the initial value only works for polynomials. Just want to make sure that you got that and don't generalize too much on that. And so put in the 1 in for the C, we've got a nice formula for our memberships. So now I have a formula. You pick the year, you pick the time. I can calculate what the membership would be as an estimate, as a projection. And then our last step is they actually wanted to find in the mid-2008. And if we start at 2005, that would be 3.5 years later. So basically, I've got t equals 3.5. I plug that in there, crunch it out. I just put it in my calculator, crunched it out, and I got 127. So we got 127 million members going on. And so that finishes up this problem. So what we're doing, a recap here, is that in this word problem, we identified that the formula that we were given was the rate, was the derivative. And the question was asking the total amounts. And usually if you start with the rate and you want to know about the totals, you're taking the antiderivative. In previous problems, previous sections, we had the total and we wanted to find how things change. Well, if you start with the total, you take the derivative. So that's basically, we're doing that circle kind of, filling in that circle of math in a way. Hey, there's the example. Hope this helps. Take care and have a good day.